Hi, my name is Nina.
And my name is Natalia. And in this session, we're going to walk you through user authentication best practices and the APIs you can use to improve your user's account lifecycle. High-friction signups, forgot password loops, and the constant threat of phishing. If you've been building account management systems, you know these are the context switch killers that drive your users away. In this session, we're going to break down the technologies that sign users in with double the speed and 4 times higher success rate. We'll look at how the industry leaders achieve great results by incorporating these technologies, like Pixiv hitting a 99% login success rate. We have prepared some tips on how to improve your user account lifecycle experience. We will cover the following topics: account creation, user attributes verification, sign in with Passkeys, and account recovery. We've also prepared a blog post for you where you can find all these topics. This blog post also covers other APIs that you might be interested to learn about. Check it out by clicking the link in the description. As you design your account management system, your goals are to phase out weak and high-friction sign-in methods like simple passwords or one-time passwords, and enable stronger, more user-friendly alternatives. Let's walk through each of these account lifecycle stages and discuss the best practices and the APIs that can improve your user experience. Your user's account lifecycle begins at account creation, but legacy sign-up forms often act as an immediate hurdle. A long list of required fields triggers frustration. And if the cognitive load outweighs the perceived benefit, the user is very likely to bounce. You can make a better first impression. Here are some tips on how to reduce friction. Consider identity federation. It's a mechanism that allows your users to sign up on your application with an account from an identity provider that they already trust. For example, Google. If the user is already registered with an identity provider, the identity provider holds some account information, such as username, first or last name, or email. Instead of entering this information on every site or application again and again, the user can simply authorize the identity provider to share selected user attributes with your application. This means your users can skip tedious forms and sign up with a single click. And most importantly, a trusted identity provider has already performed user contact information verification. This means you won't have to perform checks like the email verification does, and the user is more likely to complete the sign-up process without context switching. Since identity federation makes it so easy to create an account, you can implement it as a default choice during the initial sign-up. We recommend the pattern federate, then upgrade. Use a federated identity approach to create the account instantly and then immediately prompt the user to create a passkey to quickly and securely sign in across user devices later. Nina will talk about other passkey creation strategies later in this session. But before that, back to federated identity. If you are an identity provider, consider using the FedCM API. The key benefit of FedCM are improved user experience and privacy. Sign-in with Google and other major identity providers have enabled the FedCM capabilities. You can find more resources on the FedCM API in the blog post. While identity federation is the recommended option, if you still need to use a sign-up form, you can significantly improve the user experience by enabling autofill. To ensure autofill works correctly, use descriptive name and ID attributes for your form inputs. Provide clear label element, and most importantly, apply the correct autocomplete values, such as new password or email, to help the browser accurately assist the user. By the way, autofill does not just save your users from typing. It has evolved into a gateway for new exciting features like email verification protocol or a unified conditional sign-in UI that support multiple sign-in methods. But first, let's dive into email and other user attributes verification. When using identity federation, a trusted identity provider has already verified some user data, such as email address. When you rely on sign-up forms, the data you receive isn't always validated. We recommend verifying it first. Email remains one of the primary identifiers for many applications. It is a stable, cross-platform communication channel that virtually every user relies on. Email serves as a baseline for billing and long-term account recovery. If your application accepts false or non-existent emails, it can create high-friction silent failure, where users never receive critical information. This leads to immediate churn as users perceive your platform as broken. Furthermore, invalid emails result in high bounce rates and higher email service provider fees for messages that never arrive. For email verification, many identity solutions rely on email one-time passwords or magic links. Email OTPs are one-time codes entered into a form, and magic links are URLs that include a one-time code so that the user can sign in by clicking it. The common downside of both of these approaches is the context switch. The user has to leave your app, find their inbox, and wait for the delivery of the link or the OTP. This friction is a notorious conversion killer. Furthermore, OTPs remain vulnerable to phishing. And as for magic links, while they point the user to the correct origin, which reduces the phishing surface, they often open in an in-app browser that doesn't have the same session data or cookie saved. And this can cause user confusion and abandonment. For example, if the user finds an unexpectedly empty cart. One of the better options is the email verification protocol. The email verification protocol allows your web application to obtain a verified email address without sending an email at all. The verification flow is completely browser-mediated. For your user, this means the complete elimination of the check your inbox friction. There is no context switching and no delivery wait time. So, how does this work under the hood? It is a three-way handshake between the email provider, the browser, and a specialized issuer. The email provider can opt in to delegate verification authority to an issuer. The issuer holds a first-party authentication cookie that proves that the user is logged in and has control over the email. When the user inputs an email on your application, the browser sends a request to the issuer to verify this email. The issuer checks the authentication cookie, signs a secure digital token, and hands it back to the browser. The browser then passes this token to the application. To enable the email verification protocol on your site, annotate the email input with the autocomplete property set to email and include an N-once property. Then add a JavaScript listener for the email verified event. When the event triggers, fetch the presentation token and make sure to verify the token's signature and claims. Note that the email verification protocol feature is still in active development, and the implementation details might change in the future based on your feedback. It is also an opt-in feature, and it is up to individual email providers to support it. Check the blog post to learn more. There are cases where you may need to verify other user attributes before finalizing the account creation, like their legal name or age eligibility. This is sometimes required to comply with local regulations. In some regions, verifiable digital identity credentials are available to support such cases. You can use the Digital Credentials API to verify user attributes in a privacy-preserving way. To understand how, let's first get a high-level overview of the Digital Credentials three-party model. The issuer. This is a trusted party that cryptographically signs the credential claim. For example, it can be an organization that issues driving licenses. The holder. This is the user's mobile device that stores the signed claim. And the verifier. This is your website or mobile app that requests the proof via the Digital Credentials API. So, to request user attributes from a digital credential, your site can call the Digital Credentials API. The browser and the operating system work together to facilitate the communication between the verifier and the installed wallets. If a credential containing the requested attributes is available, the operating system prompts the user to share it with the verifying site. The verifier receives only the requested information and checks its authenticity directly with the issuer. Meanwhile, the user receives a comprehensive disclosure of exactly which data is being shared. Remember the federate and then upgrade pattern? Following a similar logic here, after you verify the user data, you can then prompt your user to create a passkey for the subsequent sign-ins. This translates into 2 API calls on your site. First, call get to verify the user attributes with the Digital Credentials API, and then call create to suggest the user to create a passkey. The digital credential landscape is maturing beyond just government-issued credentials. The Digital Credentials API provides the necessary transport layer that connects your application with the user's mobile apps. It is a versatile tool for sharing different types of verifiable credentials, from certificates to boarding passes. As long as the user has a compatible wallet app holding a credential from a trusted issuer, you can use the Digital Credentials API to verify that data. And that wraps up our recommendations for creating a user account. Now your users are set up and verified. Let's move on to the next step. From here, I'll pass it to Nina, who will tell you about the best practices to let your users sign in.
Thanks, Natalia. A smooth sign-in experience is important because it sets the tone for the entire user journey. There are many different options, and that's a good thing. Different users may have different preferred sign-in methods, such as passwords, federated accounts, or passkeys. We strongly recommend that you support passkeys for your users. Passkeys are an easier and more secure alternative to passwords and OTPs, and are phishing-resistant. First, let's see how you can offer passkeys alongside different options consolidated in a unified UI. Starting in Chrome 148, the immediate UI mode can help your user select a credential that is immediately available to sign in. It presents a UI with the available passkeys or passwords saved in their password manager. When multiple credentials are available for the same account, the browser intelligently selects the most appropriate option, simplifying credential management for your users. Unlike other passkey requests, if there are no credentials available, the browser will immediately return an error without showing any UI. Your website can then navigate the user to the standard sign-in page. To use the API, first check availability by calling getClientCapabilities. Then check the immediate get property. Once that's done, call get with the UI mode property set to immediate. We recommend setting the password property to true. If you add the password property, the API may return either a password or a passkey assertion. This ensures that the call has the highest chance of succeeding for most of your users. We're also exploring ways to support federated accounts in the immediate UI mode. Your normal sign-in page can still fall back to conditional UI. Conditional UI takes advantage of the form autofill user experience and allows passkeys to appear directly in the browser's autofill suggestions when the username or password field is focused. Check out our blog to learn more about conditional UI. Alright, now that you know how to leverage passkeys for sign-in, let's talk about creating them. You should prompt new users to create a passkey during or after sign-up. First, check if the user has a passkey provider available by calling getClientCapabilities and checking the Passkey Platform Authenticator property. After checking, call create to create a passkey. Make sure you set the Authenticator attachment attribute to Platform. This tells the browser to focus the UI on locally available credential providers. For your existing users, we recommend requesting automatic passkey creation using conditional create. This feature lets your website trigger passkey creation without showing any prompts. Adidas implemented conditional create and saw an 8% uplift in passkey creations. To use conditional create, make a normal create request with mediation set to conditional. In Chrome, if the password used matches the one in the password manager, the browser can silently enroll a passkey in the background with no additional prompts. Many platforms are also seeing a boost in conversion simply by notifying their users about passkey benefits. For instance, Pixiv added a security confirmation screen recommending passkeys as a faster, more secure way to log in. That one simple screen bumped their passkey adoption rate by 6% among new users. Another good practice is to make sure your implementation handles a failed passkey creation attempt. If a public key fails to save on your backend, send a signal to the passkey provider with the Signal API. We'll talk about this API in more detail later in this section. And finally, don't forget to notify the user about passkey creation. You should always let the user know immediately when a passkey is registered, for example, by sending an email or an app notification to help defend against unauthorized credential additions. It's important that your user's experience is consistent, not just in the browser, but across all the user's devices. To ensure a smooth cross-platform experience, you can establish a verified relationship between your website and your mobile apps. For your Android app, specify the association using the digital asset links file at assetlinks.json on your server. You'll need to include the application's package name and its SHA-256 signing certificate fingerprints. Add the handle all URLs and get login creds relation. And don't forget to update your app's manifest file to enable Passkeys. This file verifies that your web origin and your native app are owned by the same entity. Without it, users won't be able to sign in on your app with passkeys created on your website, and vice versa. Now the user has passkeys. Let's make sure your application follows best practices to keep the experience as seamless and stress-free as possible. Imagine your user deletes an account or revokes a passkey on your website, but the passkey remains in their passkey provider. The next time they try to log in, they'll see a passkey that will fail when the server doesn't find the associated public key. The Signal API can help you by ensuring your user's passkeys don't get out of sync. Call Signal unknown credential when your backend detects a sign-in attempt with a credential ID that doesn't exist in your database. This tells the credential provider that the passkey is no longer useful, which hides or deletes it from further logging attempts. In addition, you should also signal the state of available passkeys. Do this after every sign-in and whenever the user deletes a passkey. Use Signal all accepted credentials to ensure the list of passkeys is kept in sync with the password provider. And last but not least, call Signal current user details to ensure the user's name and display name shown in the passkey list are kept in sync. Consistently calling Signal API methods ensures the prompt the user sees next time they sign in is accurate. Let's talk about another essential component of a great user experience. You want to give your users control over their passkeys. Here's how you can do it. First, users should be able to add multiple passkeys to their account. This is vital for resilience. If the user can register passkeys from different providers, they have a backup method that doesn't involve falling back to a weak password if a provider is inaccessible. And it makes signing in across different ecosystems easier. It's also a good practice to provide a dedicated page where your users can see and manage all their passkeys. For example, you can integrate passkey management with the same page where your users expect to manage their passwords or second-factor authentication. Make sure the user can easily locate this page, and the page has a centralized passkeys section. Users should be able to view, add, or remove passkeys. And don't forget to notify the passkey provider about any changes using the Signal API. On this page, you should display the passkey provider name. You can use the AA GUID to look it up, like Google Password Manager or Bitwarden, and display its logo. Check out our blog to learn more about AA GUIDs. You should also clearly indicate whether a passkey is syncable. If your user registers a non-syncing key on their work PC, they won't be able to use it on their home laptop. Use the backup eligible bit, or BE, on the create response to infer this information. And that's how you build a great user sign-in experience. For the next phase of the user account lifecycle, I'll pass it back to Natalia, who is going to cover things you need to know about account recovery.
Thank you, Nina. Finally, let's take a look at the worst-case scenario: account recovery. You might be thinking, what happens if the user loses their device or deletes a passkey by accident? We have recommendations in place for you to help your users access or recover their account. We've talked before about how passkeys are synchronized and end-to-end encrypted. If a user loses their phone but has a passkey saved in a passkey provider, such as Google Password Manager, their passkeys are securely backed up in the cloud. The user can sign into their Google account on a new device, enter their Android device screen lock or their Google Password Manager PIN, and access their synced passkeys on the new hardware. And with that passkey, they will still be able to sign into your application. Many other passkey providers also support synchronization and end-to-end encryption. If a user loses access to all the passkey-enabled devices, you can still fall back to user-verified attributes. For example, You can let the user sign in through the federated account they originally used to sign up. Even if the user did not use a federated account originally, you can still verify their email address, for example, using the email verification protocol or any other methods we've discussed in this session. And with these methods, you can always help your users restore access to your application. These were our top recommendations. We've covered the best practices for every stage of the account lifecycle. Now you know how to reduce user friction during account creation, how to verify user attributes, how to implement Passkeys for the best sign-in experience, and how to help your users recover their account. The ecosystem evolves rapidly, and your coding tools must keep pace. Today, AI coding agents can accelerate how you build your identity solutions. So, we've also prepared a set of skills that will help your coding agent follow the best practices. You can review all these recommendations we've discussed and even more in the blog post. By following the best practices, you're fully equipped to build more secure, phishing-resistant, and user-first identity layer.
We are Nina
And Natalia from Chrome. And we'll see you in the next one. Happy coding!